Now that my board is calibrated, we'll try again. Like I was saying before, we are now going to use the skills that we reviewed on Friday, which was how to factor quadratic, and we're going to use those today to solve quadratics by factoring. This is our second style of solving quadratics. The first one that we did was solving by square roots. So when we had a quadratic that was written in vertex form, all we had to do to solve for x was use SADMAP, PEMDAS in reverse order, to isolate x. Most important thing about that you had to remember was when you cancel the exponents with a square root, it creates a plus or minus, because most quadratics have two solutions. We discussed the fact that solutions to a quadratic are actually the x-intercepts, the places where this graph crosses the x-axis. Well, we have really already done this last chapter when we were graphing all the different forms of quadratic. When we graphed intercept form, the most important thing that we found was the x-intercepts. Those are actually known as the solutions. So what we're going to be doing today is we're going to be taking quadratics that are in standard form, factoring them to bring them to intercept form, and then just finding the x-intercepts. That means solving for x. So here we go. Solutions of a quadratic are where the graph crosses the x-axis. Okay, we've already talked about that. I have over here the graph of y equals, and it's factored, intercept form, x plus 2 times x minus 6. So I want to know, what are its solutions? Well, like I just said, its solutions are places where it crosses the x-axis. It's x-intercepts. And in intercept form, all you have to do is tell me what makes the insides equal 0. So our solutions would be x equals -2 and x equals positive 6. Those are the solutions. You just tell me what makes the insides equal 0. X equals -2 and x equals positive 6, and that's it. That's not new. It's the exact same thing we did last chapter when we were graphing intercept form. Cool? It's not hard, right? All right. So if it is already factored for you like this one, oh man, life is good. You don't have to use the Lizzie method. It's already factored. You just tell me what makes the insides equal 0 and you're set. Well, the second one's easy, right? I mean, right here. What does x equal? What makes the inside equal 0? -5. Yeah. Now the other one. How do we solve for x? Well, you're supposed to tell me what makes the insides equal 0, right? So what you could do is you could do it the hard way, and this is the hard way. You could set the inside equal to 0 and solve for x. So I could add a 1 to both sides. That would give me what? 2x equals 1. Then divide both sides by 2. And that's how you're going to get that x equals 1/2. Would you like to see the easy way? Here's the easy way. If you remember back to what we did Friday, the Lizzie method, remember the very last step of the Lizzie method was, if you still have a fraction, you take the number that's on the bottom of the fraction and you move it to the front of x, right? We could actually, when solving for x, this is only when solving, we could technically, quote unquote, undo the Lizzie method step, and we could move this 2 back to underneath this. So we could think of this as saying x minus 1/2. So now you can easily see that x is positive 1/2. And you see, and this is why I like the Lizzie method so much, because if I'm solving using the Lizzie method, I can get fraction answers one step faster than if I wasn't using the Lizzie method. I don't want to have to say 2x minus 1 equals 0 and solve for x every time. No. See, if you know the Lizzie method, you just undo what I like to call the Lizzie step. Move that coefficient back to the bottom of the fraction. Boom. And just tell me what makes it equal 0. Lewis, question for me? I mean, yeah, you could, well, 1/2 is the answer. But I'm just trying to give you the fastest way to see it, the easiest way to see it. You can do it this way, which will always work, or you could cheese it and undo the Lizzie step, which will also always work. So yeah, when they're already factored, life is good. I know it's not part of the notes, but I do want to just add this real quick. You've seen things like this before. You guys remember how to solve this? This is already factored. This is intercept form. I mean, obvious one right here is x equals -4, right? But what about that one on the outside? You guys remember what happens anytime there's an x outside the parentheses, what its answer is? It's always 0. So just reminding you that anytime there's an x on the outside of the parentheses, its answer is automatically 0. And that's a pretty important concept. Okay, I just wanted to make sure that was there. Make sure that we're all on the same page. Literally same page of the notes, taking the notes. Okay. So yeah, when they're already factored, life is good. But when they're not factored, we are going to have to solve by factoring. Converting standard form to intercept form. I'm going to use the Lizzie method because I like it. Let's see. A is 1, B is -2, and C is -24. Going to build my table over here, looking for two numbers that will multiply to A times C. A times C for us is 1 times -24, which is -24. And we need those two numbers to add to our B value. Our B value is -2. It would be great if you could see them quickly. If you can't, that's okay. Just start listing out all the different ways that you can multiply two numbers and get -24. But the two numbers that multiply to -24, which means one's positive, one's negative, that add to -2 will be -6 and +4. Those two numbers do multiply to -24. They do add to -2. So we're in good shape there. This is where you write your two sets of parentheses. You put an x in the front and a fraction bar in the back. And then the numbers that you found are -6 and +4. -6, +4. And you cannot forget the most important part of the Lizzie method, and that is dividing by a. But a is 1. So when you reduce your fractions, you're just left with this. X minus 6 times x plus 4. And now you can easily see what makes the insides equal 0. Yes, sir. Nick, what can I do for you?
I know that a equals 1.
Yes.
Like what do you take that?
It's the number that is in front of x squared. So since there's not a number there, it's automatically a 1. So a is always in front of x squared, b is always in front of x, and c will never have an x. Okay? So we can see now x equals +6 and x equals -4. If we were to graph this thing, that is where it would cross the x-axis. Not bad, right? Not bad at all. Now this one down here, give myself a little more space. Maybe. Let's try that again. What's happening? There we go. Okay. The very first thing you're supposed to do whenever you're factoring is look for a GCF. There's not always one, and you know what? There isn't one this time. No GCF. That's fine. I'm going to go ahead and identify my A, B, and my C. A is 3, B is -5, and C is -2. This will allow me to set up my t-table. Looking for the two numbers that will multiply to A times C. Our A times C is 3 times -2, which is -6. We need these two numbers that we find to add to our B value of -5. Don't fall into the -2, -3 trap, please. -2 times -3 is +6. So what two numbers will multiply to -6? That means one positive, one negative. That add to -5? -6 and +1. That'll do. So y equals two sets of parentheses. X is in the front, fractions in the back, and then the numbers you found. -6, +1, and you know what? I'm just going to reiterate, order of the parentheses does not matter. So if you put x plus 1 over first, that's fine. It's the same answer. Please don't forget over A. Now we reduce fractions. Well, 6 over 3 is 2. But yeah, this one doesn't reduce. I am not going to move that 3. The reason why I'm not moving that 3 is because I'm trying to solve for x. That just means you tell me what makes the insides equal 0. First one, positive 2. Second one, negative 1/3. Let's be really clear here. If I was just telling you to factor, you would not be finished until you move that 3 to the front of the x. But because I'm saying solve, I don't care if you move that 3. Either way, the answer is going to be x equals negative 1/3. And this is why I like the Lizzie method. It gets me to my solutions one step faster. You guys want to ask me any questions about that? I mean, we're kind of quiet. Unfortunately, we didn't get to practice our factoring skills, but we're factoring now. We'll factor again tomorrow, so it should be okay. Mid-chapter test will be Friday of next week, the 20th. And we will cover a couple more skills before then. A couple more skills. We're going to get to play with imaginary numbers for a couple days beforehand. And another... No, that's it. That's the last skills on the test, other than what we've done so far, will be imaginary number skills. There is still another method for 2 more methods for solving, but those are after the mid-chapter test. Okay, ready to rock and roll. So what makes this one a little bit different from the others is it doesn't say y equals. Okay, well I was being a little bit remiss on the other examples. I was never supposed to solve for x until I set y equal to 0. So in these other examples, I cheated a little bit. I was supposed to say 0 equals x minus 6 times x plus 4. And down here I was supposed to say 0 equals, what was it? X plus 1/3 and, was it plus or was it minus? It was plus, right? X minus 2. I was supposed to have said 0 equals, because that's what it means to be a solution. You find an x-intercept. You're on the x-axis. And when you're on the x-axis, y equals 0. So you actually can't solve by factoring until it equals 0. This first example, then, it doesn't equal 0 yet. We can make it equal 0. Add 12 to both sides. It doesn't have any like terms on the left. It's 4x squared plus 19x plus 12 equals 0. Ooh, 12, okay. It's only getting worse. So we erase that 2 and fix it. There. This is where we look for it. Yes, sir. I only added the 12 to both sides because I can't solve by factoring unless it equals 0. Yeah, so it's cheating to try to factor a side and then solve, quote unquote, if it doesn't equal 0. And actually, it won't even work. When I say cheating, I mean it doesn't work. The only way you can solve by factoring is if it all equals 0. Because you're literally saying, oh, the y value here is 0, x-intercept. We now have it all on one side. It's set equal to 0. We can solve by factoring. First step is look for GCF. And, well, once again, there's no GCF. Okay, whatever, no GCF. Not a big deal. A, B, and C. A is 4, B is 19, and C is 12. Oh, goodness. All right, these numbers are going to get a little big. No worries. We're okay. We're smart. Trying to figure out which 2 numbers multiply A times C. Our A times C is 4 times 12. I'm going to remind you your next test is no calculator. 4 times 12 is 48. 2 numbers that they need to add to is our B value of 19. Now, I said it to you a little more than a week ago, but the number 48 comes up often. It's kind of a special number. Two numbers that multiply to 48 that add to 19 are 3 and 16. You see, if we've memorized our perfect squares, this kind of thing becomes easy because we've had to reduce the square root of 48 a few times. And 3 times 16 is 48, and yes, they add to 19. 0 equals, and you see it already says 0, so just 0 equals, two sets of parentheses, x's, fractions, and the two numbers you found, positive 3, positive 16. Both of them over your a value. A value is 4. Pound. Reduce your fractions if you can. The right one reduces, the left one does not. I'm not going to move the 4 though because I'm solving for x. Again, if it just said to factor, I wouldn't be finished until I moved to the 4. But because it says solve, I can get away with leaving it like this. I can see my two solutions now. Negative 3/4 and negative 4. Ta-da. The classroom's a little quiet today. I mean, it worries me, to be honest with you, that I don't have questions being asked. I can hope that that means it's easy. Experience, though, tells me that's probably not the case. Experience tells me more than likely it's that you have no idea what you don't know, right? So, I don't know.
Mr. McCutcheon?
Yes, ma'am.
Can you explain where you got the 4 again, please?
Which 4? The red one, the blue one, the green one?
The red one.
Oh, there is no green one. This 4 that I put underneath the 3 and the 16?
Yeah.
It's this. It's always over A. Whatever your A value is after you've pulled a GCF. Now, this one had no GCF. So the A value is always going to go underneath the two numbers you find in your T table.
Thank you.
Mm-hmm.
I have a question.
Yes, Samantha, what can I do for you?
Okay, so how did, at the end, how did it become negative? That's what I don't understand.
Okay, so why are we switching the sign? Remember,
Yeah.
we'll just for a second. Let me go back to the original slide here. You see this graph, what we're doing is we're trying to figure out where it crosses the x-axis, right? If you are here, it doesn't matter what the x value is, the y value is 0. This is at negative 2 comma 0, right?
Mm-hmm.
That's because you're asking yourself, what makes this happen?
Oh, okay.
And then
That
you
makes
subtract
sense.
2 from both sides, and that's how you get to here. So the only way, the reason why this works is because we can actually say, and I can use this example down below. This is a number inside these parentheses, and this is a number. And what we're doing is we're saying, okay, when I multiply these two numbers, I'm going to get a result of 0. The only way that happens is if one of the two numbers equals 0. So we're asking ourselves, what would make each one of those two numbers become 0? And that's why we're using the opposite symbol. Because if you plugged in a negative 5 right here, you would get 0. That's why we're switching the signs. Now, we're not showing the work of, okay, subtract 5 from both sides, because I don't think you need to. You can just look at it and go, oh yeah, the opposite symbol, and you're good to go. Okay?
Thank you.
You're welcome. Next, and oh yeah, okay, down here. And this is the first time that it's going to happen in these notes, but it's not the first time you've seen it. I did it a couple times on Friday. The very first step whenever you're solving or factoring anything is to look for a GCF. This one has a GCF. 12, 14, and 4, they can all be divided by 2. So we pull that number to the front. We do have a GCF. I'll write it over here because I've been using my right side for the T table. GCF is 2. So the first thing I need to do is pull that 2 to the outside. I'm undistributing a 2. What's going to be left in here is a 6x squared minus 7x plus 2. The quadratic that's inside the parentheses that is where you're going to identify your A, B, and C. So A is 6, B is -7, and C is 2. When you go to finish the factoring using the Lizzie method and you know the over A part, you have to make sure that you used A equals 6, not A equals 12. T-table, and this should probably be the hardest part for everybody. Two numbers that multiply to A times C. Our A times C is 6 times 2 is 12. Two numbers that multiply to 12, and I need those two numbers to add to be equals -7. Oh, okay, check that out. I have to multiply two numbers and get a positive result, but when I add them, I get a negative result. That can only happen one way. Well, specifically two negative numbers, and Lewis has already identified them as -4 and -3, or -3, -4. It doesn't matter what order you say them in. There it is. Let's say you didn't instantly see it. Okay, well then just list out all the ways you can get a 12. 1 and 12, 2 and 6, 3 and 4. And then you go, uh-oh, well, all those add to positive numbers. That's right. I have to try the negatives. So -1, -12, -2, -6, -3, -4. One of them will work. I promise. Zero equals, okay, I've set y equal to 0 now, so now I can solve. 0 equals, don't forget the 2, please, because on your test, I'm going to say, hey, factor this thing. And if you forget the GCF, then your answer is wrong. When you're solving for x, if you forget the GCF, well, you know, be honest with you, you'll probably get away with it. But I want you in the habit of keeping it around. That way you don't get anything wrong on my test. What do we find? -3 and -4. Our A value was 6. Both of these fractions reduce. X minus 1/2 and x minus 2/3. Again, if I was asking you to factor this quadratic and the directions weren't solved, but just said factor, you're not finished yet. Yes, Nick?
What was the purpose of like remodeling the equation, essentially dividing everything by 2 and multiplying it?
Well, I'm not actually multiplying it, I'm undistributing it. That way I can see what this thing is made up of. I'm trying to break it down into all of its small parts, basically. And in the next chapter, there will be more places where you can cross the x-axis. And a lot of times, one of those answers will come from an x that's outside the parentheses. So we're always trying to be in the habit of bringing the GCF to the front. Also, another reason why you want to do it, Nick, is because could you factor this thing before you pull the GCF? Sure you can. But your A times C would be 48. And you'd be looking for two numbers that multiply to 48 and add to -14. That's a lot more difficult than two numbers that multiply to 12 and add to -7. So if we pull the GCFs at the beginning instead of the end, we get to deal with smaller numbers, which makes our lives easier. You could do it in the wrong order and still get the right answers, but it's not worth the amount of effort that it's going to take. We can now see our solutions, and there are only two answers. X equals +1/2 and x equals +2/3. If you recall back to the very first slide, I wrote a y equals 1/2 x, and then I think I put an x plus 4 inside the parentheses. We said when there's an x outside of the parentheses, its solution is automatically 0. Right here, there's not an x outside, it's just a 2. So it doesn't have a solution there. It's just a vertical stretch or shrink. It's just a 2. We have to have it, though, in case I ask you to factor the quadratic. I mean, it just says, hey, factor this quadratic. If you lose your GCF, that is not the same quadratic. You don't have the same solutions, but it's not the same quadratic. So just trying to stay in good habits, keeping that GCF around. +1/2, +2/3. If you got any questions for me, please feel free. Ask. Yes, sir.
Are we going to do all the factors quadratic?
Are we today? No, because we are factoring all of them, and then we're solving at the very end. So this is actually one step more than just factoring. if you wanted to have this thing 100% factored, let's just say the directions were to factor the quadratic, I'll do that over here. You would have to take right here, and it would say y equals, you have a, actually I don't have the amount of space I need right there, so okay, the panel is struggling. Come on, I'm trying to erase. There we go. See y, oh my gosh, come on. Wow, that's frustrating. There we go, y equals 2 on the front, and you would have to move both of those denominators to the front of the x. So this is 2x minus 1, and this one is 3x minus 2. That's what it would look like if I said factor the quadratic. That's all that's different, yeah. So when you're just factoring and not solving, when you're just factoring, you would just take the bottoms of the fractions and move them to the front of the x. And you just make sure that you don't lose your GCF. That's it. When you're solving, though, you get to be a little bit lazy. You can solve it one step early before you have to move any of the numbers. That's it, though. Last slide. Let's see what's got. Cool. So this first one is a little unique. It doesn't have a C value, does it? But before you do anything, step 0 is look for GCFs. And yes, this thing has a GCF. What is it? It's 2. That's part of it. What else do they have in common? Something so obvious, you might not even realize you should say it. Well, no, I mean, yeah, but they are both even. That's why I could pull a 2 from both of them. But what else do they have in common? I'm going to say it. You're going to go, oh. They both have an x. There it is. Yes, they both have an x. That means your GCF is not just 2. The GCF is 2x. I have to undistribute a 2x. So I'm not just dividing by 2 anymore. I'm dividing by 2 and I'm stealing one of the x's. So 4 divided by 2 gives me a 2. There was 2 x's. I stole one. Minus 6 divided by 2 is 3. There was only one x. I took it. That's factored. That's it. You don't use the Lizzie method because there is no C value. Anytime the C value is missing, your GCF will involve the x automatically. Since we're trying to solve for x, what I would do is I would undo the Lizzie step, to be real with you. And I would set it up like this. I'm undoing that last Lizzie step. I'm taking the 2 from the front of the x and moving it back to the bottom of the fraction because now I can see my 2 solutions very easily. Once again, I took this number and I moved it back underneath the fraction bar. It was factored before I moved that 2. I only moved the 2 so I can easily see the answers. The one inside the parentheses now is very easy to see. Positive 3/2. But what is the answer from the 2x on the outside? Is it inside parentheses? Lots of people. I know Lewis has checked in, but guys, is it inside parentheses? Graydon, is it inside parentheses? Oh, okay. So if it's not inside parentheses, its answer is automatically 0. It's automatically 0. Naughty, was that a question or were you showing me a 0? She was showing me a 0. Anytime there's an x outside the parentheses, its solution is automatically 0. It does not matter what number sits on the front of it. It doesn't matter if it's positive, negative, fraction, decimal, unimportant. X on the outside, answer is 0. All right, let's come down here. Last example of the notes. This one's also unique. It doesn't have a B term. Okay, well, we'll get there. First things first, GCF. And yes, there is a GCF. What do negative 36 and positive 16 have in common? 4. But I would like you all to see that the front of this thing is negative. When the front is negative, there is a negative GCF. Every single time. Even if that negative GCF is just -1. Anytime you see the front be a negative number, I want you to say there is a negative GCF. Even if that negative GCF has to be -1. That's fine. Trust me, it's going to make your life easy. So we're going to say that this GCF is -4. Please remember that when you divide by a negative, your signs are going to switch. So negative 36 divided by -4 gives me positive 9. I didn't touch the x's. 16 divided by -4 gives me -4. This is ready to factor. To be honest with you, the way I'm about to factor it is the hard way. But that's probably because most of you forgot the easy way from Algebra 1. And that's okay. We will review it chapter 4. So for now, we're just going to continue to solve everything the exact same way, and that's factoring by the Lizzie method. Remember what I told you. A is always in front of x squared. B is always in front of x. C will never have an x. A is in front of x squared. B is in front of x, and C does not have an x. B is in front of x. Is there just a single x in there? Do you see an x with no exponent in there? You don't. So then what number must have been in front of it? A 0. Because the x term does not exist, the number in front of it must have been a 0. I could have written it like this, -4, and then in parentheses, 9x squared plus 0x minus 4. I don't want to. I just want to see that b is 0. Two numbers that multiply to a times c, they will add to the b value. Well, the b value is 0. A times c is 9 times -4. That is -36. I need to multiply two numbers, get -36, and they need to add to 0. So what does that make those two numbers? Well, the only way I can add two numbers and get 0 is if they're the exact same number, one positive, one negative. What do you got for me, Junior? Or was that a question? Huh? Oh, okay. It was a question, but you figured it out. So what two numbers multiply to -36 and add to 0? Sam?
-6 and 6.
-6 and +6. There it is. They had to have been the same number. One positive, one negative. Let's go ahead and set it to 0. 0 equals, got our two sets of parentheses. Uh-oh, look what I did wrong. Forgot my GCF. I'm waiting for the computer to catch up with me, though, because I'm trying to erase, and it's having a hard time. There we go. Forgot my GCF. Don't want to lose the GCF. Cool. Got my parentheses, x's and fraction bars. X's and fraction bars. The two numbers are -6 and +6. The a value we're dividing by is 9. Both of these fractions reduce to 2/3. So if x minus 2/3 times x plus 2/3. Remember, if I was telling you to factor, you wouldn't be finished until you move those 3's to the front of the x's. But since we're solving, we can just say what our answers are. Our answers are x equals +2/3 and x equals -2/3. There it is. Strange example. So what I'd like to know is, are there questions out there that I can help you guys with? You see, I left the weird ones for the last slide. Yes, Lewis? When B is missing, they will always be the same number, 1 positive, 1 negative, because they had to have added to 0. This is actually an Algebra 1 factoring trick. It's called the difference of two squares. I don't know if you guys remember that terminology, but it's like whenever you're trying to factor a squared minus b squared, it factors to a plus b times a minus b every single time. But you don't have to know that yet. You can just go, yeah, b was 0, so I must be looking for the exact same number, but 1 positive, 1 negative. That'll happen like that every time. Anytime b is missing. So, recap, if c is missing, like the first example on this slide, GCF has an x in it. If b is missing, like the last example on this slide, then your two numbers will be the same number, 1 positive, 1 negative. That way they can add to 0. And that's going to do it for today. Now, the homework won't be due tomorrow. Tonight's homework won't be due tomorrow because tomorrow's a whiteboard day. Quote unquote whiteboard. However, if you think you have mastered the stuff and you want to do the homework tonight, you can. Any question for me, Lewis? No? All right. Cool. And then we'll stop the notes there.